Hello, my name is Paul Rahmani, and my project is called the Hyperfocus Glasses. Focus has become one of the rarest human abilities. Every second, there is something that pulls our attention away, whether that is a notification, a thought, or a distraction. And I wanted to create something that doesn't just help us measure focus, but also helps us to actually reclaim it. So I built this. The idea was to combine neuroscience with computer vision into something that is practical and wearable. A pair of glasses that can monitor your attention and help you stay in deep levels of focus.
Here's the blink tracker in action. The system counts blinks in real time so you can see your concentration levels as they happen. As you can tell, when I'm blinking, the blink count increases. And when my final score drops below 4 out of 10, there's a buzzer that goes off. Here's the EEG working. And I want you to notice how the readings change as the focus levels shift. Here's me turning the device on. That was just an initial buzz, ignore that. Okay, now notice how when there's an increased level of beta wave activity, the attention level also increases. And hence the final score, the final focus score also increases. Now I'm going to show the user interface. Now as you can see, it plotted the recent data on a user interface. I will talk about that very soon. So I built a simple dashboard that displays blink rate and EEG results together. This lets users track their focus patterns over time, learning from what worked and what caused distractions to further improve their focus. To improve immediate feedback, I used Arduino-controlled LEDs that change color based on focus. Red for distracted, yellow for moderately focused, green for focused, and blue for highly focused, which all complements the software dashboard.
So in essence, the product actually uses a brain chip to process different brainwaves to identify how focused the user is. It is then coupled with OpenCV's computer vision software to track blink rate in order to provide the most accurate measures of focus. Now let's see this in action. So first of all, I'm going to turn on the device. And as you can see, it is going to start tracking my focus. Now I'm going to run the application. These are the EEG score values. For example, low beta values are indicative of high levels of focus. As you can tell, when the beta values increase, and you can also see it down here, the final score value increases as well because it means you have a high level of focus. Now, we can also see the blink rate. So when I start to blink, it starts to track my blink rate, and hence the BPMs actually increase, and this indicates that the user is becoming less focused as the BPMs are increasing. Okay, now we can also see a dashboard of this here, where this actually graphs the user's focus over time in real time to provide them with the most data to be able to actually improve their focus. And if you had not yet realized, the sound that is playing is called binaural beats. It is scientifically proven to enhance focus through this like 40 hertz sort of sound that puts you into the state of focus. And there's also this buzzer sound. Let me start to blink a lot. When your focus levels drop below 4, a buzzer sound actually goes off to indicate that your levels of focus are low and that you need to start focusing. Okay, and this is basically the essence of my project. This is how this whole system comes together, and improves user focus. Thank you for listening.